Hey guys, how's everybody doing? Let's do a quick sound check here since I'm back in the shop. Okay, looks good. Yeah, so now that I'm back in Florida, back at the shop, uh, had at least I have equipment that I'm used to. So thanks guys for the uh, for the 100 milestone, 100 episode. Appreciate you guys getting on there saying that. It's been a minute since we started this thing, but I'm glad you guys stuck with me, and we're making it happen. So hopefully from 100 on, we're gonna have some good stuff going on. I got a little work to do to the Cup car. I have somebody coming to look at it in a couple weeks, so we're going to try to get that wrapped up, ready to go on track for some road racing. And then once that's gone, we'll get back on the Vet Hawk and get that project rolling along again. Tomorrow I'm going to go up and work on the Allneck C60 Chevy truck, vintage race car hauler. So hopefully I can get the wiring complete on that thing and get the motor fired up. That would be a huge milestone. That project has taken a lot more time than I had originally planned on. Of course, having to do it off-site has made it a little bit more complicated, but sometimes you just have to do those kind of things. Hey, thanks, Chris. And I said it in the chat, but I'm glad. Hi, Ryan and Dave and Rick. Glad you guys are in tonight. So last week I had a few hiccups on the live show, but we were able to get through it using my laptop and not really knowing. I tried to test everything out, but it didn't work. When I went live, everything got messed up. But you guys hung in with me. I got it going. And believe it or not, that was our biggest show of total views. We had a really good concurrent view level. It was in the 20s, but we had, I believe it was 510 clicks on that show, which is the largest show we've ever had. So hopefully we'll do something similar tonight. Trying to change things around a little bit, trying to keep it interesting, trying to get some more tech stuff going, so that you guys have something to come and watch instead of just me rambling on. But so just to get everybody caught up in shop news and stuff like that. So we were on vacation last week. We got back from Rockport, Mass, late Sunday night. Yesterday basically was just kind of getting everything caught up in the office, and worked on Leo's cylinder head a little bit, getting the oiling system done on that. I had been today machining an adapter for the Allneck to space the coolant fan, so we have room for the radiator and all that. The water pump on the 8.1 liters a little different than the 366, even though they're both big blocks, but so far everything was looking good. That's going to all fit. Worked on Dave's car yesterday also, using the new wire crimps to instead of having the bare wire going into the Dakota Digital, which uses the screw type clamping system on the wires. My stereo buddy showed me a trick with nice, can't think of what the name of them was. I'm looking down because I've got one on my desk here. But it's basically a crimp terminal that's made to go into one of those type screw-in clamps, so you don't have bare wire going in. So that really made it nice. Hey, Bill, how you doing? Yeah, thanks a lot for the 100. Yep. Can't believe we got in here. But yeah, so we're making good progress. I hope to have Dave's dash back in his car, and we got some wiring, a little bit of AC lines to make for the in the engine bay, and then we're ready to get that thing road tested and get it finished up. So Chuck's dry shaft came in, so I went in and stuck that in yesterday just to get that up off the floor. So that's in. So now the drivetrain is fairly complete as far as the large components. We just got hook up shifters and cooler lines and stuff like that. But we're getting really close to having the drive line, the large parts all bolted in to where we can start doing wiring and then start the turbo kit process. And then, of course, I had to put a third gearbox in my dually in the shop truck. For years, I've used remans on gearboxes and stuff like that, and no problems. But in today's age, nothing seems to work good. So within 6 months, not even 6 months, 3 months, I've had 2 reman gearboxes in that truck. So it started leaking just before I left on vacation. So I ordered a brand new box, and that came in while I was gone. So yesterday I went in and slapped that in the truck. So at least I've got wheels and, making progress. So it's been a busy 2 days. Oh, and I went over and worked on Scott's 63 Le Mans, getting his dash cluster back in and changing the check valve, the flow valve on his power steering pump to try to get that going. So he's going to try to actually take that to a chin one of the driving schools up in Sebring. So he's got 2 weeks to get that car back together. So I ran over and got that done too. So it's been a busy 2 days. So unfortunately, that didn't allow me to get a lot of time for the live show tonight. But what I wanted to do, starting on episode 100, was I wanted to go through fabrication. And so the first thing I thought of, welding. I was talking to Rick a couple weeks ago, and he had a wire feed MIG welder that used flux core wire, and it's a hard deal to work with. And he was converting his to gas, so he called me and asked me a couple questions, and I kind of gave him what information I could give him on it. And it just made me think about, that's something that we're all at one point going to have to get into, some type of metal fabrication, whether it be welding to put a hot side pipe together, or a muffler in your car, or rust repair. And then, of course, with all of that, you have all the tools that go along with it. You're going to need, if you're doing sheet metal work, you're going to need some hammer and dollies, some snips, some cutters of some sort, cut off wheels, etc. And then you'll have to sanders, and then a welder to weld the new panel back in. Anytime you're doing any frame fabrication or modifications, putting in different motor mounts, hanging a new steering box, or going from a steering box to a rack and pinion, something like that. You're always going to, at some point, going to require some metal fabrication and some welding. So I thought that would be a good topic to start off episode 100 with. Rick says my welds don't look anything like yours. Well, mine don't look all that great either, but welding is a practiced art, kind of like golf or anything else. You can't just pick up a welding gun and weld and expect to weld perfect. If you're on Facebook or on Pinterest or any of these other channels, Instagram, where people show pictures, and you see what they call weld porn, where they're showing fantastic, beautiful welds on different kinds of metal. Obviously, those guys are full-time welders, and it's an art. There are quite a few guys, especially on Instagram, that actually do artwork out of welding. They actually will take a plate of stainless, and they'll draw out a pattern, and then they'll use weld to create that pattern, and grinder, and use some other things, but they actually make art pieces out of it. So it's one of those deals that practice makes perfect. So even though I have been welding for a long time, I usually will practice on a piece before I start welding a finished final piece, even to this day, because it may be 3-4 weeks between a welding job, and that welding job may only be a 5-minute job. So it's hard to keep up your practice like that. But with anything else, practice makes perfect. So let me go ahead and I want to go ahead and give you guys the 4200 update. So let me bring this up. Go. So here's the new oil line. I've got it made. I've got a exhaust piece made. And as I talk to you guys, let me see if I can. No, it won't let me go back. There was a plug, a galley plug here in the. You know what? Let me go back so we can, for the people that may have not have been here for the last one. Oh, I know why, because it was here. Let's see where we're at. So with the 4200, we had an issue with. Hey, John, how you doing? We had an issue with the 4200 where we were getting dry exhaust valves, mainly because the exhaust has got a lot of heat in it, but there wasn't enough oiling going to them. And the gesso lifters that are in this motor are solids, and they do not have an oiling system in it. So we figured out that the only way we were getting oil in was around these caps. It was kind of squeezing oil out, and then the camshaft would start flinging around. Well, obviously we had an issue, and that's not enough oil. So kind of video. So this was my idea to put some oil lines across here, like they do in NASCAR and endurance racing, where they put oilers to spray cooler oil on the valve springs and get that all working. Hey, Mike, how you doing? So that's what my plan was.
What we're going to do is drill a hole.
And some little videos I made, just drilling a hole in the tube and laying it out.
All right, so after several,
went ahead and got the plug out and found out there was a machined hole going into the oil cavity, so that was perfect for us to pick up our oil from. Then I come up with these mounts to hang the lines along the caps. So that's kind of a catch up where we were. So where's my pictures? All right, so let's go back here. I thought I had pictures on there, but I guess I didn't. So here's our exhaust side pretty much done. I still got to cap this line at the end here, and I still have to do the intake line. I decided not to spend too much time yesterday on it because I had other things I had to get finished with, but at least we got it moving forward. So here's a close-up of, I machined a piece with an O-ring in it so it sits down in the galley hole, and then put an 1/8 inch pipe thread up here. Hey Chuck, how you doing? So with a T piece, I guess that's a T on the street. It's not on the run, but it's -4 on both sides, and then 1/4 inch stainless line with the oiler hole pointing straight down on the retainer on every line. So here, I went ahead and oiled it up. So using an oil can. So I don't know if I had any sound on that. Let me replay that again. So basically what I'm doing here, See if I can get one picture with the oil squeezing out. So there's a hole on every retainer, and right now the line is open all the way to the end. So when I'm pumping oil with a hand pump, there's no restriction. It's filling the whole trough. That's why you don't see it streaming out very heavily, but you kind of get an idea what's going to go on there. Now, next week I'll have a video of the rails all done, and I'll pressurize it with my AccuSump. Right now that's up in Riviera Beach at the Allnick because I need to prime that motor before I turn it over. But I think it's going to work out really well. So my next goal will be get the intake tube done, plug the ends, and then I'm going to go ahead and use the AccuSump with 3 quarts of oil, 60 pounds of pressure on it, and then I'm going to inject the oil and stopwatch basically how long it takes for 3 quarts of oil to go through the cam journals and the oilers, and that'll kind of tell us if our restrictor is the right size or not. Now, I am pretty sure that once I do that, we're going to have a small steady stream of oil coming out every hole in both rails, so it should pretty much put a deluge on the intake valves, the intake and exhaust springs, which should help splash more oil everywhere and keep the push rod or the valve stems lubricated enough that we don't have a sticking valve anymore. So that's our goal with the 4200. I'm gonna try to get that all situated this week, and then I can coordinate with Leo when I'm gonna go over to Arcadia and assemble the cylinder head back on the engine, get the timing set, and get the motor fired up and get it ready to go on the dyno. I'm not thinking I'm going to be able to get all that done and dyno the engine in one weekend, but we'll see how that works out. Maybe I might stay over. I've got to line it up with Blow-By Racing. They've moved to Fort Myers, so they're only about 55, 60 minutes away from Leo's place in Arcadia. So, and he's got a brand new mainline hub dyno. So we'll be able to run that on the hub dyno and actually be able to make trans brake, work on the boost builder on the trans brake, and also do some quarter-mile passes so we can see how the boost curves are and how the fuel curve is, so that the next time we go to the track, we'll be ready to lay down a number. And I just did see on one of the news feeds I get that I don't know if they've closed Bradenton, but they're doing a lot of major work at the track, and it looked like it was going to be closed till July 12th at the earliest. They're going to make a new road going into the track, maybe move the ticket booth when you come into the gate, maybe put 2 in and do some other stuff. But I think the entrance road is going to be their biggest thing. They're not going to be able to run while they're doing that. Now, once they get that done, the other improvements around the bathrooms and redoing the tower and stuff like that, that stuff they can still run the racetrack for tests and tunes and stuff like that while the other work is going on. So happy to hear that track needed those upgrades. But anyway, that's given us some more time to get all the things corrected on Leo's car. And even though it's not good turbo weather right now, hopefully we can get to the point where we can get some clean quarter-mile passes, even if it's in the heat, so that we can go ahead and get ready for when the cold air comes, and we can make some big fast passes. As I was saying last week or the week before, one of the guys that's running a real full-bodied car like we have, Calvin, he just did a sick summer and won his class. I don't know, I didn't follow it because I was on vacation, but I know they did win their class. I'm not sure whether they took their V8 LS car or they took the Camaro with 4200 in it. But anyway, he's getting pretty close. He's in the 850 range, and so it's time that we get Leo's car back together and really make a statement with a nice mid 7-second pass. So we got a big gap on everybody once again, and then we can continue from there and see how far we can go. Because watching what Calvin has done on his channel, Nivlac 57, if you guys want to check him out, he's been pretty much until recently been working on junkyard engines, and he's been in the low 9s, knocking on the 8-second door with junkyard engines. So now he's got a little bit more of a built engine, nothing like what we have, but it just shows the durability, or he's shown the durability of these engines and what they can take. And you can see by what he's doing and by what we're doing, we're hardly even scratching the surface with this motor. Leo's motor, aluminum rod, good pistons, big cylinder wall, thick cylinder walls, ported head with big, huge camshafts, solid camshafts, where most of these guys are still running hydraulic. We're only running 20 pounds of boost. All these guys are all up in the 30s. So it just shows that that we have a long way to go to maximize this engine. But in the past, we've had so much durability issues, we couldn't really concentrate on that. But now I think we are getting really close to having all the durability issues finished and fixed. So once we get through the dyno session and get through at least one track test session, that'll tell us where we're at. And from there, we can start leaning on the motor a little more when the weather gets better. So that's kind of where we're at with the 4200. So I guess we can go ahead and get into the welding. That's what we're here for. So we're just gonna kind of do an overview on welding. I did a little short video. I used some of the video for the thumbnail, but so there's a bunch of different welding processes. Now there's laser, and then back in the old days we had oxygen acetylene and oxygen propane welding or brazing. But we're not going to go over that stuff. It's not the best kind of welding to do, and so for what we're doing, it's really not what I would want to do. When the old school guys would use coat hangers and braze in steel, but the problem with that is there's no flux core and no gas umbrella for the welding process to happen. So what ends up happening, you get porosity in the welds, and they're not good welds at all. So we don't even want to get into that because it's not good welding. So this is an AC/DC arc stick welder. It's another style one. You've got your ground, you got your electrode holder, and you put in an electrode. Then you can go to a MIG. Now on a MIG, this one is showing it can be either set up for gas or for flux core. Flux core, you don't need any gas. The welding wire actually has flux in the center of it, kind of like a soldering, a piece of solder with flux core in the center. Flux core is okay. If that's all you've got, go ahead and use it. But whenever you have a flux melting into your weld puddle, it's always going to be a dirty weld and probably not as strong as a good gas shielded weld. So we always, if you can, you always want to go gas shielded. Now this one got stuck in between. It's another stick welder, a little like suitcase style. Here's another Lincoln welder, and it's got the gas setup on it. It's got a bigger torch cup, and the electrode comes out of the center. Here's an Eastwood with a spool gun. The spool guns, trying to stretch this picture out. There we go. Spool guns are usually used for aluminum welding. You can use them on steel if you have a small steel spool in there, but it's kind of a big, heavy tool to hold in your hand and hold steady while you're trying to make a weld. But on aluminum, the aluminum wire is not thick enough or strong enough to send through 20 feet of cable to your TIG torch. So they use a spool gun because it only has to go this short little distance, and it'll work like that. Now, the reason this is kind of heavy is because there's a little motor in here to drive the aluminum wire out of the torch. So it's kind of a heavy unit, not really good to use. But if you're stuck and you got a MIG gun and it uses a MIG welder and it's got AC and you want to do aluminum, it will. There's a Miller-Matic, another MIG gun welder. Now this is a little bit closer to what I have. It's a newer version. This is a TIG machine. Now you got your connections for water, your electrodes, ground and power, and you can do AC, DC welding. This is for TIG welding. This is, if you're going to buy a welder from scratch, I would suggest to try to move into a TIG welder right away rather than a MIG, but we'll get into that later. Here's another Lincoln TIG welder, and one of the main things with a TIG is you're feeding in your filler rod, and you usually have a foot pedal or thumb pedal, a thumb control to control your heat. See, Mike's in. I can remember my uncle used coat hangers to weld in patch panels on his Chevelle back in the 80s. Yeah, a lot of my dad did. My buddy Bobby in Boca that does a lot of metal work, he's done that also. But like I said, the problem there is, and we're going to get in that, is there's no inert gas shield over top of your weld. So any kind, when you weld, you're getting the metals to a molted state, and so most sheet metals and chromoly and all those kind of metals, they all have different ingredients in the weld. It's just not straight carbon steel. There's different components to make up whatever strength steel or stainless or chromoly or titanium. So it's not just a straight product. So what ends up happening is some of those ingredients in the steel will start melting at different rates, and without a gas shield, oxygen gets to it and it oxidizes the weld. So what ends up happening is a very weak weld. But back in the day, it was very easy to do, and guys would do it. Now, they did have flux core brazing rods. Now, that was a better way of going, because you had a flux core that would make a puddle, a gas puddle around your weld. So the welds were better, but you're only welding brass. So brass is way softer than steel. So again, it still wasn't a perfect solution. So back to, here's another Miller. This one's actually got a MIG gun, and a TIG torch, two different size TIG torches. This is a non-water cooling machine, so it's gas only. In fact, that's what I have also. So we'll get into some of that later on. There's another unit, a Lincoln square wave machine, which actually most of your TIG welders can be a stick welder also. So that's kind of why the TIG machine is a really good machine. If you wanted to really optimize a TIG welder, you can buy a wire feed attachment, and it'll usually come with an electrode holder, so you can do MIG, TIG, and stick weld all with one unit when you get into the TIG welders. That's why I say, if you're going to spend the money, look at what's available in TIG machines instead of buying 3 different machines for 3 different uses, and they'll have a good use in the shop. So before I was talking about the flux core, and just kind of show you here, here's a gas MIG, and this is a flux core MIG. Both of them use the same gun, the same machine to make the voltage and amperage, but you can see here with the inert gas, it's a much cleaner weld, because now the gas is making a shield, and when you got the molted metal and the wire feed going in, which melts also, it's got a shield of gas to cover everything, and that keeps all the contamination out. Now, one bad side of MIG welding is you see all the spatter here. There's a lot of spatter that comes out of MIG welding, so it's not the cleanest weld. You have to go back and do a lot of cleaning. The other thing with MIG, no matter which system you're using, whether it's flux core or shielded gas, is that you have one temperature setting and you pull the trigger and weld. So when you're welding like sheet metal and stuff like that, it becomes a little bit trickier, and that's where you have to do a little bit more practice. Sometimes you may have to, instead of doing one continuous weld, you have to do large spot welds, moving back and forth, say like skipping every 2 inches and going back, and then get to the end and then start at the beginning and keep stacking your welds to get a finished weld. Because if you continue welding at one heat setting, you'll need it hot to start, and as you weld, now the steel starts getting warm and you can back off the heat. But on a MIG torch, you'd have to stop and adjust the machine. You can't continuously weld without having heat build up. So that's one downside of a MIG machine, but it's good. It works great when you're welding heavy stuff, anything from 90,000 steel up to 1 inch steel. A MIG welder is great for that because you can crank the heat up, send the torch in, and really lay out some welds. So it's good for quick fabrication of heavy metal. But for sheet metal work, it's a little bit more touchy. Building headers and aluminum hot and cold pipes and stuff like that. We need more heat control. That's why you'd more want to go to a TIG machine. Now, on this side, you can see this is flux core, and you can see the flux is melted. It did make a gas cloud, but it also melted into the weld, so it's a very dirty looking weld. So this weld's going to require wire brushing and or grinding to get the weld exposed and to have a nice clean weld face. Now when you go to TIG, you don't have to do any of those things. Excuse me. So here's what I'm talking about, shield gas. So in a MIG weld, you have an inert gas. Usually it's CO2 and argon. It's 75% CO2, 25% argon. They call it STAR gas as an acronym. And that's what you want to use with MIG welding. And you have wire coming out of off a spool in the machine, and you can control the speed of the wire. And then you've got a ground cable, and you've got a power cable going to your torch tip, which then gives a positive charge to your wire coming out of the tip and into your metal. So the wire comes out, makes contact, creates an arc, and then the shielding gas then shields as the metal is pulling. So you see here in this dark red here, that's the puddle of weld. And as the wire's feeding, you'll get this flame coming across, and then this outer bluish green color, that's your shield that's protecting your weld from oxidation getting into your puddle. So that way your metal stays clean and you don't have all the porosities and all the other stuff. Now, I don't have pictures of it yet, and this is for further newer shows, part 2 and so on. But if you start seeing a lot of bubbling in your welds when you're done, it doesn't look like a stack of coins, then your shield gas is not strong enough. So if you're welding outside or where there's a breeze, you have a fan blowing because you're hot, you have to increase your pressure for the shield gas so you can keep that puddle of or shield of gas over top of your weld and keep your weld clean. Same thing with your TIG weld. This is a TIG weld here. Inert gas. Now this is typically argon, straight argon, but since a TIG welder, you have different welding rods that you can feed in. You can weld all kinds of stuff. You can weld bronze, silicon bronze, stainless, titanium, stainless, chromoly, and aluminums, and all those different things, even cast iron. you would change your welding rod, your filler rod, to whatever appropriate rod. You may have to change your fixed tungsten electrode torch and the gas, but typically argon, for our sake of conversation, is the gas you would use all the time for both aluminum and steel, chromoly and titanium actually. So that kind of stainless, that kind of covers the gamut that we would have in our workshops building our hot rods. So that's what, same thing. You've got your metal puddle here, your molted weld pool. You've got your torch flame coming from your the arc coming from your fixed tungsten electrode, and you've got your puddle of shielding gas. Now the beauty of TIG welding is we have different welding cups we can use. We have different diffusers we can use, so we can change the size of the shield gas immensely, and just makes it much cleaner for doing different kinds of welds. We'll get into that in a little bit. So here's a guy doing stick weld. He's got his handle up here, electrode holder, and then you got a welding rod, and I think I've got a slide later on, but the welding rod actually has flux core dipped. They're dipped onto the rod. So as you're burning as you're making the weld, you'll get a puddle, a shield as the flux is melting, and that gives you your shielding for keeping oxidation out of your welds. There's another guy just doing welding, and this is where stick welding is really good. If you're welding heavy steel, pipe, stuff like that, stick welder's quick, easy. You can they have all different fluxes and all different rod diameters. When I was in high school, I was working in Knoxville, Tennessee at Quality Welding, and that was a co-op thing. I was getting credit for work, and I actually built quite a bit of the I-beam for the 1980 World's Fair. And so we would use 6013 rod. It was a 1/4 inch welding electrode, and the flux core surrounding it was almost a 1/2 inch in diameter. And I could weld 1 inch plate to 1/2 inch thick 12 by 12 I-beams for the base plates for the structures for the buildings. And you could lay that with one single pass, and you could get a great weld bead out of it, and you just have to chip the flux core off. If you use like a 70 series rod, a lot of times the flux core will actually peel up for you. It's really cool how some of it will work. Now this guy's using a MIG gun, and it's a little bit different. You know, you got a gun, you got wire coming through the cable. You pull the trigger, it feeds the wire. You have a speed. You have two basic knobs on your MIG welder. You're going to have wire speed and amperage. Amperage is going to be heat. Wire speed is going to be the speed that the wire comes out and fills your puddle. So here you can almost see a shield there. The light is hard, but you can see the spatter coming off the weld also. So it's a very dirty weld process. If you're trying to do something clean, like sheet metal work, or you're trying to make something, you want to make an engine stand or something like that, more than likely you're going to have to do some grinding to get all the spatter off of the material. Otherwise, it's going to have all these little welded BBs all over your material. But it's a very fast welding process. You can a weld like that will take you less than 30 seconds, where if you're TIG welding it, it could take you 2 or 3 minutes. So it's just different ways of doing things. When you're in the shop building stuff, you have to think about what you're building, and what welding process you want to do. There's just another guy TIG welding. Fabrication in a job site where you're doing heavy fabrication, MIG is usually the preferred method, because you're trying to get speed, especially when you're building large equipment, big frames and stuff like that. You can get away with that. The spatter isn't as big of a problem, so when cleanup isn't going to be a problem and end results aren't a big problem, MIG is a quicker way to go. Then we go to TIG. Now, TIG welding is great for very thin tubing. Guys can actually TIG weld razor blades together or 2 soda cans together. So, I mean, it's very temperature controlled. You usually will have a rheostat, either gas pedal or thumb control on your torch to control the heat. Typically, most people will just use a foot control because it's easy while you're welding. You just run, just like a gas pedal, all the way down, all the amperage, back off, and it's less. And then you can feed it, so you can go back and forth, hot, cold by popping the throttle up, in and out, in and out, in and out. And then you use your filler rod. You make the molten weld puddle with the torch, and then you add the filler rod to that puddle, and that's how you create your weld. And just again, here's a kind of different cup that he's using. Another thing with the TIG torches, they're very light, and they have different tools and accessories, so you can control all that stuff. But it's really good for getting in tight places. You got glass torch tips where you can actually see through them. They don't last as long, and they're very delicate, so they're very easy to break. So you have to kind of keep that in mind. But very controllable welding. That's why anything that is an exotic metal, that's the way it's typically going to be welded. So here's kind of what's going on. As we talked about earlier, you got your puddle of molten metal. That's your components that you're welding together. You have an arc flame coming off of the electrode, and then you've got the shield puddle that's keeping it all protected, so no contaminants can get into your welds. And then you use a filler rod to make your puddle. So these are all been dipped in to make your weld. Now these welds are cooling off, and they've already been shielded, so they're nice and clean. This is kind of the same thing we've already gone over. This is TIG with a filler rod. So once you start using the torches and stuff, this is a stick rod. Now you can see it's kind of hard. This picture is kind of blurry, but there's a metal rod with flux over top of it. This is the part that would actually be in the handle, and then you'd burn off the other side. And this is probably a 70 series rod because, like I said, when you do a good weld with that, you can see the flux will actually come right off the weld by itself, or you can just tap it and it falls off. Again, you can see all this contamination on the outside. That's the edges of the flux residue as it was making the shielded puddle, and of course a lot of spatter. Okay, so some of these I don't have in order. I didn't get them all set up, but your welding rods are going to have a series of information on them. When you're welding steel, ER70 is usually what you want to use. So that's going to, you've got the first 2 digits are your electrode or rod series. Then your tensile strength is in the second series, and then whether it's a solid or flux core would be here, and then shielding gas and stuff like that would be your outside number. But your ER70 S2, 3, that's where you want with your filler rods. That's what you with your MIG wire and with your TIG filler rods. That's the rod you want to use for mild steel, chrome moly. That's going to be what you're going to use the most of. So let me break away here for a second off the screen and get these, see where we want to go here. I didn't get these in order at all. All right, so here's just some pictures of some of the welds. This is an aluminum weld, and you can see nice beads there. One of the things with aluminum welding, when you're TIGging it, you can see this little bit of white on the sides. That is where the shielded gas is actually cleaning the aluminum. So when you're welding aluminum with a TIG welder, you're going to weld it in AC current. So it's alternating current. So the ground and power are switching back and forth. Fancier machines, you can actually control the on and off time for negative and positive. But what that does is that reversion in voltage helps the shielding gas to actually clean the aluminum as you go. So it makes sure that there's no deposits that are going to get into your weld and contaminate it. Here's a steel or chromoly weld. You can see the little dimes. You know, everybody says stacking dimes. That's basically what you're trying to do. And you can see the way the weld wrapped around where the heat concentration was. That's the nice thing about TIG welding, is you can control that heat where you need it. Now here is a MIG welded joint. So this is done pretty well here. This is not enough heat, so the weld is puddled up on top of the metal, and it didn't melt into the two pieces of metal. So this section of pipe right here, there's nothing holding it. If that was the way the weld was all the way around, you could smack this with a hammer and it would fall right off. But this section right here is a decent weld. You can see how the weld puddle is kind of melting into each pieces of the metal as it was melting together. But you can notice the little, let me go a little closer here. You can see these little debris marks here, and that's actually contamination getting into the weld because it wasn't cleaned properly. So that's another issue with MIG welding. And then, of course, the spatter. You can see all the little BBs that are all over the place here. Those are all going to have to be knocked off or ground off to get the pipe cleaned up. So that's why MIG welding is a good welding practice for regular steel. But if you're getting into any of the exotic metals, stainless, chromoly, titanium, aluminum, TIG is a much better way of going. That's why, like I said, if you're going to buy a machine, a TIG machine is probably the best way to go. Here's another aluminum weld. You can see again how the high frequency switching of the AC and DC, because you're running AC current, alternating current, how it actually cleaned the aluminum around the weld puddle, and it made a really clean weld. Just a very good so all right, I'm going to show you that in a minute. I made a little video because I'm trying to work on the camera for welding. So why did this not open up here? It's going in the wrong place. All right. Here. There's another steel or chromoly weld. You can see when the weld is real clean, how it has different colors from the cooling of the weld as it's going around. You got golds, coppers, purples, blues. You can always, whenever you get those kind of colors in your weld puddle, you know you've made a really nice, strong weld. Here's a piece of titanium, or stainless rather, and you can again you see how the color changes are in the weld, in the weld. So it was a good clean weld, and that's one of the big takeaways, is you always want to clean, no matter however you're welding, steel, stainless, chromoly, aluminum. You want to really make sure your metal is clean. Don't try to weld through painted products, powder coated, anything like that, rusty. So if you're putting in, if you're doing sheet metal work on your car, where you're doing floors or your patch, rust patches and stuff, you want to get in there with a grinder, knock the heavy stuff off with a 36 or a 60 grit, 80 grit, something like that, and then use like a Scotch-Brite style cookie to polish everything out and clean it so there's no contaminants left, front and back, and then you'll have a good metal to put your weld on. So again, the shielded gas is trying to keep all the contaminants from getting into your weld puddle. So any dirt or contaminants that are left on the steel are going to get in your weld puddle, even though you've done all this work to keep out of it or keep it out. So always clean everything. If you really want to be have really good welds, take acetone and clean all the steel before you even weld. And if you're TIG welding, take acetone and wipe all your welding rod, your filler rods before you start welding. And we're going to get into this in part 2, but you want to get good containers to keep your material in. So all your welding rods are, especially for TIG, are bare metal of some kind of composite. So if they're in a high humidity area, or they're not in a sealed container, they're going to start forming rust before you even weld it. At that point, you either have to take steel wool and clean all the rust off of the filler rod, or you throw it away and get new filler rods. So cleanliness is very important when you're welding. Can't emphasize that enough. And when you get really technical in your welding, you can do welds like this. And some people call this walking the dog or walking the cup, and actually what they're doing is they're rolling the cup back and forth and making two puddles, but as they move along, instead of having one stack of dimes, it's actually two stacks of dimes sewn together. It's a very artsy way to do it. It has its place when you're trying to do a nice weld for different metals. Very tricky setup to do. And here's a really, as we say, weld porn. Here's a really nice chromoly weld, and you can see how clean all those welding are. And of course, you can see the discoloration from heat. So it was a nice clean weld because it got the colors. If the metal was dirty, even if you had the heat right, this would all be gray. It wouldn't be colorful like this. So the way that is done is cleanliness, and there's no contamination in the weld joint. So again, cleanliness is one of the most important things there. All right, so let me get some stuff here. So when you're MIG welding, a lot of times your MIG welder inside the door will have a chart like this, and it kind of gives you some information on what you want to use and stuff like that. Like you can see here, DC positive, steel MIG welding. There's your gas, 75 argon, 25 CO2, so that's your star gas. This is a DC negative for self-shielding, so it's got no gas. That's a flux core. You've got DC positive for your aluminum MIG gun, which then you're going to use 100% argon. Stick rod, 6011, 6013, or 7014, 7018. And of course, stainless steel. On a MIG gun, you'd want to use 100% argon. But they give you wire size, and then you pick the steel gauge that you're working with. A lot of this sheet metal and stuff we work with is either 14 or 16 gauge. So you can say, okay, I'm going to go 16 gauge, and I'm going to do MIG gun with star gas. So it would tell you your temperature is going to be on F, and your wire speed is going to be on 6. So you set your knobs there, and you pull the trigger and do a test piece. And if you've ever listened to anybody weld, which I'll show you next week in part 2, if the weld sounds like it's frying eggs, then you've probably got a really good heat and wire speed feed package. You can listen to. That's one of the cool things about MIG welding, is you can listen to the weld, and you can pretty much not even have to look at it and know how the weld is going to come out. Now, obviously, you have to look at it to make sure you stay welding on the joint that you want to weld in, but you can hear it and you'll know when it's when you're getting a good weld. Okay, so then what's this one? Well, this is for stick welding, and these charts you can download off the internet also. But for stick welding, here's your electrode: 6010, 6011, 6013, 7014, 7018, and then diameters of the welding rod. And it'll tell you what kind of amperage you should be burning the rod at, and whatever the metal thickness is. So, like I said, when I was welding the steel beams for the World's Fair, I was using a lot of 6011 and 6013. So you can see 7 32nd rod, over 3/8 thick, and amperages at 160 to 250, or with the 6013, 210 to 300. And you're running that a big amperage because you need to make a lot of heat. Now, you can go into your 7014 and 7018, and it won't. The 70 series isn't as strong as a weld. It's more of a pretty weld. The 6011, 6013 is more high tensile strength, and the 70 series is a little bit less in tensile strength. And again, when we were looking at the ER 70, that is what this 70 is, and ER 60 would be these rods. So the lower the number in the ER, the higher the tensile strength is. And then we can go to I didn't get a good filler chart, but there's a couple things you got to look at when you're when you're welding TIG welding. So you've got in stick welding, your electrode is the steel going into your weld puddle, and that's what's making it all happen. And that's as it's burning, as it makes the arc, the metal is dropping in droplets of molted weld into your weld puddle. So that's making it itself makes your torch or your flame. In a MIG, you've got your wire feed coming out, and the wire feed's doing the same thing. It's creating a power to ground, which is making an arc, and that starts melting your wire, and that's what creates your flame. And the wire coming out of the gun is what makes it drops. It goes into molten state and goes into your weld puddle, and that's what creates your weld. In TIG welding, you have a torch that is just a torch. That's all it's for. So you have different materials you can use in the torch for different kind of metals, because it's going to have the tungsten will, they call that tungsten, it's in your TIG torch, and it's going to create the weld arc, but it's also going to melt. It's a wear item, and it's going to drop into your weld puddle, not at a big rate, but it will. So you have to pick your tungsten for whatever you're trying to weld so that it doesn't contaminate. So all your tungsten rods for your welder, they usually come in about a 6-inch length, and they'll have a painted stripe on the top. And then you can go to a chart like this, and it'll tell you what it's for. So you've got your TIG mode, which is going to be AC or DC, or it can be used either one. You got oxide percentage, and that's how much of oxide it's carrying. It can drop into your weld. And then you've got the different components that are in the tungsten rod. So the tungsten rod, just like metals, have different chemical components in it, all mixed together, and that's what creates the different kind of tungsten rod. So green is pure tungsten, AC only. So that's typically what you would use for aluminum welding. Then you can get the threaded, that's for DC welding. Serrated, that's DC or AC. Lanthanated, that's multiple use AC, DC, and then you got zirconiated. That's going to be brown and white. That's going to be for AC only. And then you got rare earth mix, where I mean typically the welding company that makes it going to have their own colors. That's something that we're never going to get in. So the main two rods that I would consider that you would want to keep in your toolbox is green and blue. I like to use the blue lanthanated rod because you can use it DC, so you can use it for all your different kind of carbon welding, and it'll also work on AC and DC switching, so you can use it on your aluminum welding. So it's one rod that you can use kind of like the general all-purpose. Now the green is a better rod for aluminum, but the blue is easier, and that way you've got one color rod in all your different diameters. We'll get into that later. There's different diameters of the rod, so that way you don't have to worry about grabbing the wrong welding tungsten rod for the work that you want to do. So I'll show you a couple little slides here, then I'll show you my little video, and then we'll call it a night for tonight. Obviously, these are spools. It's going on the wrong screen there. Okay, so some of these I didn't check them before. So this is typically what you're going to a TIG torch kit. So you're going to have your torch, and this has actually got a handle, so you can use a push button if you want to use a push button. You have your different tips here and collet for whatever wire you're using. Here's your different collets for your tungsten. You're going to have different tungsten diameters. And then we have different caps. So you're going to have your torch. The porcelain is going to come out the front. That's your shield, your welding cup. And out the back of it is going to be these handles, and that's going to keep the complete piece of tungsten in a shield of gas. The whole thing will be loaded with gas. And that's what you're going to weld with. This is a different kit that kind of gives you all different kind of cups. You got some glass cups, you got some diffusers here, and stuff like that. So that would be a really good kit you can buy to do multiple kinds of welds. I'm going to go over some of these videos, pictures later. Wanted to show you, where is the... So this is the cup that I like to use. I got another picture of it, I think. But so this is a gas TIG torch with a small cap. So what you do is you cut your tungsten in 3-inch pieces, and then you can use the short cap, so you can get around like roll bars and stuff when you're working in tight places. And this is a Furic 12 cup. So you can see it's got a screen in here, and that's a diffuser. So what they do is, actually this guy Furic was actually a NASCAR chassis builder and back in the day, and he started creating his own welding supplies so that he could get his job done. So typically your tungsten is going to stick out from your cup. Whatever the diameter opening of your cup is going to be basically the maximum stick out of tungsten you can do. So if you had, let me go back here. Yeah, so on here, you can see with these little cups, your tungsten's barely going to stick out. And then with these Pyrex cups or these bigger cups where they got the bigger opening, now you can stick your tungsten farther out from the cup. And the reason that is when you're welding something flat, you don't need the tungsten sticking out. But when you're welding in between into a V, the tungsten with short coming out short will not reach the part, and you're gonna have a big huge flame. The tungsten's not gonna be in the shield right, and it's gonna burn off very quickly, and it's just not gonna be clean. So with these style cups, you can stick the tungsten out farther and get in there and get a really clean weld joint. And here's another picture of the ferrite cups, and you can see that he's got 2 layers of screen, and then the piece back here that this screws onto has a screen also. So you end up with 3 screens for the gas to come out of. So what that ends up doing is it makes the gas come out the first screen at a high pressure, and it diffuses it. It hits the second screen, diffuses it more, hits the third screen, diffuses it even more, and becomes a very large shielded covering for your weld. And that's why you can stick the tungsten out so far and really get down into a tight V and weld and not have to worry about contamination. So these cups are great. The Pyrex cups are great, but you drop them or hit them on something, they shatter. These cups are really indestructible. It was a really great thing that he came up with, and they work fantastic. So that's pretty much, I got a couple of little pictures, but we're kind of gotten over where I kind of got the point across what I was wanting to do. Let me show you this little video. There's going to be some dark spots in it because I've been working with the dark lens, and I'm trying to figure out how to videotape some welding for the next couple shows. So let me get this started here. So here it is. You can see that the filter makes it so dark you can't even see anything. I'm gonna have to work with lighting and stuff like that, but once I get started, I can turn the camera on and go back over, grab the welding torch, and then start my weld. There we go. So you can see the flame, and you can kind of see the puddle coming out. Now there's a magnet on here, and that's disturbing the magnet's trying to draw the flame to the magnet. Now I was just putting a tack in, now I'm rotating the bar. This is a little 3/4 inch rod end tube for the cup bar for the rear end, for the round road course rear end, so you can put load on the side load on and create more negative camber. Still going. Just take the second I done, clamp the bar and rotate it. So in the future, I'm going to try to use 2 cameras and some type of backlight. All right, so here I'm making the second spot weld. You can almost see the outer shield. Let me stop this for a second. You can kind of see out here. That's the kind of you can almost see the gas shield, and this is the flame coming from the tungsten. You can see the tungsten is red hot, and it's melting, making a weld puddle. This angle we still haven't got a weld puddle yet. And then I've got the filler rod in my other hand, and I'm dipping it in, and that's how I'm making the weld. Now, the other thing you want to do with a MIG or with a TIG is once you've stopped the weld, you can hear the gas continue to run. You want to hold the torch over the weld until everything cools off and the gas times out, so that you still don't get contamination when you end your weld, because it's still molten. Here I'm welding, I'm doing a rosette, so there's a hole in the tube, and the rod end or the tube end is solid underneath it. So I'm filling that in to combine the inner solid steel to the outer tube. And again, you hold the torch till everything cools off, and you can move on to the next thing. Now I can go ahead and go to the outer edge and start welding it. So again, I got to work on so you can see the weld puddle itself. I haven't gotten that mastered yet. I'm going to work on that this week. That's going to really make this show a lot more. Again, I got to rotate the tube to the next point. That's what this black spot is. I'm actually doing this thing. Didn't get a chance. I'm going to edit this, but and here you can kind of see there's the ferrite cup and there's the screen. So that's what I was talking about. and that's what creates a big, huge cloud, a shielding cloud around the weld joint to keep contamination out. Unfortunately, I didn't get a chance to edit this. There's a second rosette. I know this kind of looks funny here. That's a spot weld, and that's where the last weld stopped because I couldn't get all the way around the tube. So that will get welded up. I know it looks a little funny there, but there I fixed that little spot, and then continue on the other side of the spot weld, go around the bar. And rotate the bar, the tube once again.
That's the rosette. $180, that's another rosette. That's because this weld here around the end could crack the end of the pipe off and wouldn't hold. But if you do a rosette down farther down, now it's got more contact patch and it will make a better joint that will not break off.
So that was a down and dirty weld on it. Unfortunately, I mean, you could see in the weld at the end when I took the filter off that there was little bubbles and stuff on the end. That's because I did not clean this. I actually slapped that together about an hour before the show, and I was kind of running out of time, and I wanted to have something for the thumbnail, so I went ahead and did that together real quick, but it's not the cleanest weld. I'm not very proud of that. And it's also zoomed in really tight. That piece of tubing is 3/4 OD with a rod end insert that's for a 3/8 rod end. So the picture looks big, but it's actually a very small component. But I'll go ahead and get the other ones welded in. I'm gonna work on getting some better view so we can try to get that the weld puddle. I've watched a couple videos while I was out of town, and they're talking about changing settings in the camera, which I really don't know anything about. I always leave the camera on auto, so I'm gonna have to work on that, but I'm gonna try to get that done so we can get some weld puddles so we can I can show you more about what's going on with that. But we'll get into this further, but you know, whenever you're welding in a tube end into a piece of chromoly, this is a piece of 058 chromoly, you always want to do a rosette, because when you weld the piece around the outer, when it's round, the chromoly behind it is very thin, and it's been heated up, so it becomes brittle there. So if you just went around the outer V V portion of that piece, it could snap behind the weld and the piece would come apart and you would have a ruined piece. But I'll show you in future episodes, they give you a big, solid, thick piece to give you a lot of thread engagement, and that goes up inside the sleeve. So then what you do is you drill 2 holes opposing sides, and they call them a rosette weld, so that you can heat up the center solid material, and then work, once you get a puddle on that solid piece, you can work it to the outer edge, and then use filler rod and attach the 2 pieces together. Now you have a spot where it could fracture, the tubing could fracture like in an accident or something, but it's not going to rip the tube end out because it's got a different shape. It's not a straight line at the end of the weld. It's got these 2 rosettes, so it quadruples the holding power of that end on that thin piece of tubing. So I'll show you some more stuff on that in the future as we get more into this. I'm going to try to do some stuff on plasma torch cuttings. I do have a plasma cutter. I wish I had a plasma table. I do not, but that may be something I might get in the future. And then we'll go through MIG and TIG. I don't have, well, I do have a MIG handle, so I mean a stick welding handle, so I could maybe show some of that too. So maybe I'll pick up some stick rod, and we'll do stick and MIG welding next week. And then week 3 we'll get into TIG, and that may take two shows. And we'll do plasma cutting, and then we'll get into, once we get through the welding stuff, then we'll go into metal fabrication. I think that's how we're going to just roll this, right, stay on fabrication for a while here for the next couple of shows. So hopefully that was some good information. I was just trying to do an overview of everything, and we'll get into more detail on each process in the future. So I know we went over a little bit tonight. Appreciate everybody hanging in there with me, and really appreciate the congrats on the 100th episode. I'm very thankful that you guys are congratulating me on the 100th episode, but you guys coming every week is what's caused the 100th episode. Without you guys coming back, there would be no 100th episode. So thank you for watching and doing all those things. And we're going to be in town for the next couple weeks. I don't think I have anything going on for a while here, so we're going to stay in the shop and try to get through some of these projects and start getting some more projects for shop updates and stuff like that. And hopefully by the time we get into the fabrication portion of the show, we'll have the we'll have the vet hawk in the shop and start doing some of the roll cage work on that and chassis framework, and we can put all this to common practice. Here's what we're doing. Here's how we did it. So stay tuned for that stuff. Thanks, Rick and Ryan, Bill, Dave, and Mike for John for throwing the comments up on there. I really appreciate it. And start writing notes for the next episode. And Chris, you too, man. Write some notes for the next episode. Like I said, it'll be stick and MIG welding. If you got questions on that stuff, throw it in there so we can put it in the chat and we can talk about it while we're doing the show. And I will get some welding pieces of metal. We'll do some stuff. I'll make some bad welds. I'll make some good welds. I'll make some okay welds. I'll make the best as I can do. Hopefully they'll be great welds, and we can discuss how it happened and stuff. And hopefully I can get the camera situated to where we can get some good weld puddle video, so you can actually really see the nitty gritty of all that. So with that, I'm going to pull the plug on tonight. I really appreciate everybody coming in. Remember, click the like button. Subscribe if you haven't. Get instant notification. It's free. You're not going to get junk mail or nothing in your inbox. You'll just get notification when we drop some new videos. And appreciate everybody coming out. Share the videos with your friends if you know somebody that's going to be in fabrication. Tell them, hey, check this stuff out, and maybe they'll learn something. Or maybe somebody will know something I don't, and they'll put it in the chat, and we'll all learn something. It's all good. This is a two-way street here. I'm not going to tell you guys I know everything. So with that, I'll talk to you all later, and see you next week.